This question may seem to be very complicated or lengthy at once, but you need to solve such questions in the following manner. First of all, it says three distinct numbers are randomly selected from the first 20 natural numbers. Find the probability that the selected numbers are in GP. So, first of all, in how many ways we can select three numbers out of 20? Number of ways is 20C3. So if you calculate 20C3, this is 20 into 19 into 18 divided by 3 factorial. 3 factorial is 6, so this goes 3 times. 19 into 2 is 38. 38 into 3 is 114. So this is 1140. So the denominator says 1140. So this very much looks like the answer, or D as the answer, if this was 10 upon 1140. So we need to find out how many ways we can form a GP. Now, if you try to make the cases as in the common ratio being 1 or common ratio being 2, 3, 4, 5, then there are chances where we can miss out things. For example, when the common ratio is 4, suppose if the common ratio which is denoted as R is 4, we'll have only one way as 1, 4 and 16. But there can be a fractional way of common ratio. Let's say if the common ratio is 3 by 2, we may have 4, 6, 9 also in GP, or we may have 8, 12 and 18 also in GP, which is little complicated to understand whether the common ratios may be fraction or not, and if in fractions, then which all possible cases. So instead of making cases, let's try an alternative and an easier method. Let's say if the three numbers are in GP, then the product of the first and the last will be equal to the square of the second, right? So that means if A, B, C are in GP, if they are in GP, that simply means A into C should be equal to B square. So only we need to do is we have to figure out pairs of such numbers whose products are perfect square, and these two numbers should be from 1 to 20. And this number should also lie between 1 and 20. Okay, so let's see how many such perfect squares we can form. How many pairs of AC are possible such that the product gives us a perfect square, and that perfect square lies between 1 and 20. Let's say one of the, let's make cases. 1 2, no. 1 3, no. 1 4, yes. Similarly, we'll have 1 9, we'll have 116. So we have three cases when it starts with 1. Let's talk about 2. 2 3, no. 2 4, no. 2 5, no. 2 6, no. 2 7, no. 2 8 is 16. 2 into 8 is 16. So that's the perfect square of 4. 2 9, no. So we need to find another value which will give us, this is 6. 8 into 2 is 16. Can we have 25? No. Can we have 36? Yes. Can we have 49? No. Can we have 72? No. That exceeds. So can we have 81? No. So this exceeds the limit. Okay. Let's see the number that starts with 3. So 3, the other number should also contain a 3 to make it a perfect square. So we'll have the product will have 2 3's, and let's say we have 2 squares. So 3 and 12 makes one pair, and next one may be 3 into 3 square. So this exceeds 20. This value exceeds 20. So we'll have only one case from 3. Let's say 4. 4 is not possible. 4 5, no. 4 6, no. 4 7. So this is 2 square, right? So next one should be 3 square. So 4 9 makes another pair. 4, we already have 2 square. Can I have 4 square over here? Yes. So 4 and 16. Can I have 5 square now? No. 5 square will make this as 25. The other number is 25, and we need to find the numbers between 1 and 20 only. So let's start with 5. So if we have 5, then the other number should also contain 5. So 5 into 2 square, which will give us a perfect square. So this is 5 into 20, that is 100, which is a perfect square. let's look at the number 6. So we have 2 into 3. The other number should also contain 2 into 3. So 6 we cannot have, or it should contain 2 cube, right? Such that it becomes 2 to the power 4 into 3. Now this is 8 into 3, that exceeds 20, so we'll not get anything from 6. From 7 we cannot have anything because the other number is 7 will have at least 4 over here to make their product as perfect square. We'll have 2 7s and we'll have 2 2s. But this again exceeds 20, so we'll not get anything from 7. Let's say 8. 8 has 2 cube. In the other number I require at least 1 2. And then I can have 3 squares such that this forms a perfect square. So this gives us 8 and 18. Let's look at the other number 9. 9 already has 3 square, so what I require over here is 4 square, very much possible. 5 square, it will again exceed. Can I have more? If I start with 10, the other number should have at least 2 into 5 into something. So this other number will definitely exceed 20 if we take 10 or 11. So these all cases will not be possible. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. We have 11 such cases. So the answer is we have 11 such cases out of 1140.